How was your weekend? So here you can see the new cost that is brought in part B, which is this 0.5x. And so when we take our original revenue, we need to subtract from it 0.5x. And when we collect the like terms, we get this new profit function, which we can use to find the maximum, or in other words, the vertex. And that will occur when x is equal to 2.125. Here we see the difference in what linear and quadratic data will look like. A linear group of data will increase at a constant rate, right? The slope will always be the same. Whereas with quadratic data, as we see here, the change in y is not going to be constant. In other words, the slope is going to be changing. And so it will be a quadratic model. If I wanted to use my calculator, you can go back and actually look at the steps and practice them yourself if you'd like. But the key things here are that we put our data into our calculator and have it predict or create a quadratic model using quadreg. And then what we would do is use that quadratic function that we're given and plug in the x value that corresponds to the year 2020. So noting, of course, that 2010 would be our 0, 2020 would be 10 years later. So the x value would be 10. All right, here are a lot of things going on. The first is in part A, what kind of solutions will the equation have? And so just to get an idea of what this function is working with, what it is we're working with, we should graph the function. And so we are given the h and the k value. So I have h equals -3 because it's x minus h. And so h here is -3. And then k is equal to 7. Well, that's my vertex. The a value is 2, which is positive, so I know it opens upward. So there's my function. And so based on that, I can say that it's going to have complex solutions, or complex roots, since f of x doesn't intersect the x-axis, right? So we set f of x equal to 0 for finding the roots, and so this will have only complex solutions, since it has complex roots. Will the function ever intersect the horizontal line y equals 5? So I can draw the line y equals 5, and clearly I can see, no, it's not going to intersect. How could I prove this? Well, if I were to set the y value of my quadratic equal to 5 and solve, I should get no real solutions or complex solutions. And in fact, that's what I would want to do. I have this quadratic, 2x squared plus 12x plus 25, right, if I FOIL this out. And I have my line y equals 5. And I just am solving this system of equations to see if there are any intersection points. So I set y equal to 5 using substitution, and then would go through and solve. Right? So if I go through and I solve, I'm going to end up using the quadratic formula. And in the quadratic formula, I'll notice that the discriminant is less than 0. So the solutions are going to be complex, and that will prove that they will never intersect. What sort of transformation would result in f of x having real roots? Well, an easy way to do it is just say, what if I brought the vertex down to the y-axis? And to do that, you'd have to subtract 7 from your function. In other words, translate it down 7 units. So a translation down 7 units would work. And the way that I would do that, as I just stated, is subtracting 7. So my new function would be 2x squared plus 12x plus 18. Of course, there are other ways to do it, and you could certainly go that route if you wanted. So here I have another graph, and I want to write the equation for this graph. So notice that it's always easier to write an equation in vertex form. And so I'm just going to write out vertex form here. And notice that I need to find the h, k, and a values. So just going back to my protocol, find the vertex, which gives me the h and the k values, plug those in, and then plug in a point. You could choose any one, but I chose 0, 1 to solve for a. Get that a is -3, so I can rewrite my function. Then I need to prove that this has the same roots as this function. And the way that I do that is by algebraically finding the roots. And so what I do is I set the function equal to 0, right? So I know where it's going to intersect the x-axis when y is 0. And then I use the quadratic formula to solve for x. And I get that x is either negative 2.15 or 0.15, which looks to be correct. So therefore we've proven that the function that is graphed is the same as the function that we wrote. Okay, so here's the solution, and before you immediately bury your head and look away, don't worry, I'm going to take you through this. So what I want to do is first sketch a graph of my situation. I have this circle of radius 1. So here's my circle of radius 1. Here's the origin. And let's start with just this line, y equals 2x minus 1. So the y-intercept is at negative 1, and the slope is 2. And so here's a sketch of my line, y equals 2x minus 1. So first off, I know there's one point of intersection, right, at 0, negative 1. And I don't quite know where this one is, but I know the x value should be positive, I know the y value should be positive. Both of them should be less than 1. And what I want to do is come up with a method for finding this point of intersection. Well, remember, when we hear point of intersection, that means the same thing as the solutions to the system of the equations for these two particular figures. So the system of equations that include this equation and this equation, the solutions to that will be the points of intersection. And so that's what I want to set up right here, and I'm going to use substitution to go ahead and find those x and y values. And so once I've substituted in to this equation, my goal being to get all x values so that I can solve for x, I substitute in 2x minus 1, and now I just need to solve this equation here. So I'm going to FOIL this out, 2x minus 1 squared. That gives me 4x squared minus 4x plus 1. And then I'm going to subtract 1 from both sides so that I can have my quadratic set equal to 0. Once I collect the like terms, I have 5x squared minus 4x equals 0, and I use the quadratic formula to solve for x. So what I get is that x is equal to 0 and x is equal to 4/5 or 0.8. And so what I can do is now plug those x values back in to my function. I can actually choose either one, but this one will be obviously much easier, and get the y value. So of course one of them I get is negative 1, and so that corresponds to the point 0, negative 1. And the other point I get is 0.8, comma 0.6, and that should make sense as well. This point could definitely have a y value of 0.8 and an x value of 0.8 and a y value of 0.6. So now that I've found those points of intersection, part B should be pretty self-explanatory, and I've just included the answers, the points here and here. For part C, this is a little more tricky because this equation here is solved for x. So it might make it hard to graph. However, there's a couple things you could do. The first is you could solve for y using inverse operations and then graph that function. And if you did, you'd get y equals negative 4x plus 4. And if you were to graph that, right, negative 4 is going to be a slope, downward slope, and so you'd have a y-intercept of 4, and it would be sloping down this way. So you can get some idea of where it'll intersect. You can see that they, probably going to be somewhere, positive in both the x and y direction, and so you get some sort of idea, and then you can go into using, solving that system of equations. So there's a couple ways you can do that. If you didn't solve for y, you can actually use this equation and the equation of the circle, just like we have before, instead substituting in for x. So you now know the x value, and so here you'll substitute in for the x value, and so you'll have this squared plus y squared equals 1, and you can solve for y using the quadratic formula. Notice when you solve for y, you'll be getting a y value back, and so then you'll plug back into your function to get an x value. So you can do that, and that'll get you the correct answer. Or, having solved for y here, you can plug in for y, substitute in for y, solve the same way using the quadratic formula as we have before, and get that your x values are going to be 1 and 15/17, And then you can plug those in to get your y value. So you're going to get 1 comma 0, which means it's actually going to intersect right here. Okay? And then you're also going to get 15/17 comma 8/17. And so that point is probably going to be somewhere over here. All right? So if you had questions with this, definitely come by and ask or send me an email. But we have done a bunch of questions that are similar to this, so hopefully it made sense. So I think I've explained this to most, but what you're looking at here is a way to incorporate I squared into the equation, because if you do, then you can manipulate much more easily, because I squared is just -1. And notice here that I to the 100th power, it's just 50 I squareds multiplied by each other. So that's just I squared to the 50th, right? I squared times itself 50 times. And I to the 1000th is just I squared to the 500th, because it's I squared times itself 500 times. And of course I squared is just -1. So then making the manipulation, the substitution for I squared is -1. And so you have -1 to the 50th, and if you multiply a negative number by itself an even number of times, you'll get a positive value. So this is going to be +1. And same is true here, so it'll be another +1. And so you have 1 plus 1 plus 1, which is 3. All right, best of luck. Good luck with all the studying. Let me know if you have any questions whatsoever, either by coming into my room or sending me an email.